Chapter 10, Section 7 deals with the equation of a circle. So this is definitely more of an algebra lesson in a lot of ways, but it relates us, brings the relationship between algebra and geometry clearly into view, that there's a distinct relationship here. Basically, when we are finding the equation of a circle, there is one point that we're really interested in, and that is the center of the circle. What is the location of the center of the circle in the coordinate plane? We're going to call that center point HK. Okay, that's HK are the coordinates of my center point. And the radius of the circle is the other thing we're going to be interested in. We're going to call that R. Now, we can basically work back to Pythagorean Theorem to explain this, and we'll spend a lot more time on this in Algebra 2 and pre-calculus. But essentially, if we look at any right triangle, and we can see our right triangle here, that if we just call these sides of a right triangle A, B, and C, like we're used to doing from just our regular geometry work, we always said that A squared plus B squared equals C squared. That's how we did a Pythagorean theorem in a triangle. Well, for a lot of algebra reasons, which I'm not going to spend a lot of time going into, this first side of the triangle, first horizontal side, can be found by finding the coordinate of a point on the circle, x, minus the center. And the second side is a point on the circle, y, minus the center. Equals the radius squared. And that is the equation of a circle. The other thing you might notice a very strong resemblance to here, because it's essentially the same thing, is a distance formula. Okay? The distance formula essentially just renames variables. So instead of R, it uses D. Instead of H and K, it uses X2 and Y2. And it takes the square root of both sides of it. But it's the same equation, actually. Distance formula and equation of a circle are essentially the same equation. And it's also the same as Pythagorean theorem. All three of them are just different ways of representing the exact same concept. But what's important here, again, is HK, the coordinates HK, in this formula represent the center of the circle, and R is the radius of the circle. And notice that it's R squared here and not R in the equation, so that's going to become very important to us. So, at the very least in your notes, I want to see written down this formula and this explanation of the things that go in the formula. We'll be checking for that in your notes. So let's take a look at this. Let's write the standard equation of the circle. The circle is shown on the left here. The center of the circle is very clearly at 0, 0, which is very nice for us. The radius of the circle, we can tell by the graph, is 3. So with the center at 0, 0 and a radius 3, we can write the equation of the circle very simply using our formula. It's x minus h squared plus y minus k squared equals r squared. Well, h and k are both 0, so that's x minus 0 squared plus y minus 0 squared equals r squared, 3 squared. And so if I simplify that a little bit, x minus 0 squared is just x squared, y minus 0 squared is just y squared, and 3 squared is 9. X squared plus y squared equals 9 is the equation of that circle. Okay? So all we're doing is plugging into the formula. Again, one that's not pictured, but when we give us the centers at 0, negative 9, the radius is 4.2. We start with the same formula. So x minus 0 squared plus y minus negative 9 squared equals 4.2 squared. Now we've got a little bit more work to do here because x minus 0 squared, that's easy. That's just x squared. I'm not going to FOIL this out. I'm just going to rewrite this as y plus 9 squared because minus negative is a plus. I am not going to FOIL out the y plus 9 squared here. That's something you'll do more in Algebra 2 and definitely in pre-calculus, but not here. And the 4.2 squared, we're just going to use our calculator for that. 4.2 squared is 17.64. And we've written the equation of a circle. So again, this really comes down to knowing the formula. If you know the formula, it's not so hard to work with. Couple more examples. Center at 0, 0, radius 2.5. Again, x minus 0 squared plus y minus 0 squared equals 2.5 squared. And then we simplify that. That's just x squared plus y squared. And 2.5 squared is 6.25. Now you get to do one. Center is at negative 2.5 and the radius is 7. Now remember, you do not have to FOIL out the binomials when you get it. But again, it's going to be multiple choice, so no big deal. Pick out the correct formula. All right, a little bit different here. I'm not going to tell you the exact radius. We could probably figure it out kind of by counting squares here. So it's not maybe the best example on earth, but it's the one we were given in the book, so we're just going to go ahead and do it. So write the standard equation of this circle. Well, the center is at negative 1, 3. Okay, so that's the first thing I notice is where's my center? My center is at negative 1, 3. So I know it's x minus negative 1 squared plus y minus 3 squared equals r squared. Okay, or that's x plus 1 squared plus y minus 3 squared equals r squared. The problem is I don't know what r is. I'm not given r. Now in this case, we could probably figure it out by doing a little square counting. We'd probably say if this is my center, 1, 2, 3, 4, it looks like my radius is exactly 5. And I'm sure it's going to work out to be exactly 5. But let's just say, for example, it wasn't exactly 5. How would we work this out? What we'd have to do is we'd have to set up essentially a distance formula or a Pythagorean theorem. Set up a right triangle. Say, well, I know between these 2 points, 1, 3, and 5, 6, that's my radius. And I know this distance over from negative 1 to negative 5 is exactly 4. And up from 3 to 6 is exactly 3. And I'd say, okay, 3 squared plus 4 squared equals r squared. So that's 9 plus 16 equals r squared. So r is 5. Okay, but the thing is, once we know r squared is 25, what number do we need to actually put in here? We just need to put in r squared. And we're all set. So there's the equation of that circle. Now again, this one we could figured out r but just by counting boxes because it is exactly on the line. A lot of circles, it's not going to work so nicely. So we're going to have to work on that. This is one that's given, and we don't have a picture drawn. We're just given the information, so we are going to have to work a little bit more. It says the point 3, 4 is on the circle, and the center is 1, 4. Write the standard equation of the circle. Okay. So the center is at 1, 4, and 3, 4 is on the circle. You come up with the correct equation. That's your second question of the day. Finally, it says, prove or disprove the point root 2 lies in the circle centered at the origin and containing the point 2, 0. So a sketch might be in order here. Okay. Center of my circle is at the origin at 0, 0. The point 2, 0 is on the circle. So if I'm going to draw this circle, and I'm going to cheat a little bit because I got a smart board. There's my circle. My center is at 0, 0. My radius is obviously 2. So that's x squared plus y squared equals 2 squared. Or x squared plus y squared equals 4. There's the equation of that circle. The question asks me, I need to prove whether the point lies on the circle. So notice I didn't even address the question to start with. I said, okay, I need to find the equation of the circle before I can even think about addressing this question. So I looked at the facts I had, center at the origin, containing the point 2, 0, sketched a picture regarding that, and found the equation of my circle. Now, does the point square root of 2 fit on that circle? Well, what I'm going to do is I'm going to substitute these values into this equation and see if it works. So the equation is x squared plus y squared equals 4. So square root of 2 squared plus square root of 2 squared. Does that equal, I'm not sure, 4? Well, the square root of 2 squared is 2. Square root of 2 squared is 2. And that's true. 4 equals 4. I've proven that that point is actually on the circle. Now, not every point's going to work. If I wanted you to check, say, 1 square root of 5, is that point on the circle? When I substitute that in, 1 squared plus square root of 5 squared, does that actually equal 4? Well, that's 1 plus 5 does not equal 4, so not on the circle. So we have to find the equation for problems like that, find the equation of the circle, then substitute in the point in question, and see if it works in the equation. That's what you have to do to prove or disprove that a particular point lies on a circle. Again, this is more of an Algebra 2 topic. We did a little bit of this in Algebra 1. It's definitely an Algebra 2 topic. It becomes very important in pre-calculus. So kind of keep this in mind. Not the main focus of our test as usually happens with these last sections, but it is something that you need to be exposed to, something you need to think about a little bit. There definitely will be problems, not so much like this, but there definitely very well could be a problem of this nature or something like that on the test that we take next week. So there you go. Good luck. We'll see you in class.